In this video, we are going to be covering parent functions, which are the most basic form of a function within a family. It's stripped down so there's no shifts, stretches, or extra coefficients. It's just the core shape. Every transformation you study later, like shifting a graph up, flipping it, or stretching it, all happens to these parent functions. So if you know these shapes by heart, you'll understand transformations instantly. So let's get into it. We'll start with the constant function, f of x equals c. In the case of the graph shown, c equals 5. The graph is a horizontal line with a domain of all real numbers. The range is just the constant c. The y-intercept is at 0c, and it is an even function. A real-world example would be a flat rate subscription service. Next, we'll have the linear function, f of x equals x, which is a diagonal line through the origin. The domain and range is all real numbers. The intercept is at 0, 0, the origin, and it is an odd function. A real-world example would be a direct proportion between two quantities, like cost per item. Next, we have the absolute value function, which is f of x equals the absolute value of x. The graph is a V shape. The domain is all real numbers. The range is from 0 to infinity. The intercept is at 0, 0, and it is an even function. It is symmetric about the y-axis. A real-world example would be the distance from a point regardless of direction. Next, we have the quadratic function, which is f of x equals x squared. The graph is a U-shaped parabola. The domain is all real numbers. The range is from 0 to infinity, and the intercept is 0, 0. It is an even function. A real-world example would be projectile motion or area calculations. Next, we have the cubic function, f of x equals x cubed. It is a S-curve graph. The domain and range are all real numbers. The intercept will be at 0, 0, and it is an odd function. A real-world example would be volume calculations or torque relationships. Next, we have the square root function. The graph is a half curve starting at the origin. The domain is from 0 to infinity. The range is also from 0 to infinity. The intercept is at 0, 0, and it is neither even nor odd. A real-world example would be physics equations for time and distance. Next, we have the cube root function. F of x equals the cubed root of x. The graph is a horizontal S-curve. The domain and range are all real numbers. The intercept is at 0, 0, and it is an odd function. A real-world example would be engineering applications with cube volume constraints. Next, we have the reciprocal function, f of x equals 1 over x. The graph is two separate curves in opposite quadrants. The domain is all real numbers except for 0. The range is also all real numbers except for 0. There are no intercepts, and it is an odd function. A real-world example would be inverse relationships like speed versus time. Next, we have the exponential function, f of x equals 2 to the power x. E can also be used as the base. The graph is a curve that rises rapidly. The domain is all real numbers. The range is from 0 to infinity. The intercepts are 0, 1, and it's neither even nor odd. A real-world example would be population growth or compound interest. Finally, we have the logarithmic function, f of x equals the log of x. The graph is a vertical slope that levels off. The domain is from 0 to infinity. The range is all real numbers, and the intercept is at 1, 0. It is neither even nor odd, and a real-world example would be a Richter scale or pH in chemistry. Why does this matter? Because every time you graph a complicated equation, you're really just taking a parent function and transforming it, shifting it up or down, reflecting, stretching or squeezing, all of that becomes easy if you can recognize the parent graph underneath. Think of it like knowing your root word before learning a new language. Now that you've met your core 10 parent functions, you're ready to start transforming them, combining them, and understanding how they model the world around us. Don't forget to like and subscribe, and check out my other videos in this playlist. Thank you for watching.